Coming to DARPA is like grabbing the nose cone of a rocket and holding on for dear life.
DARPA is a place where if you don't invent the internet, you only get a B.
A DARPA program manager quite literally invents tomorrow.
Coming to work every day and being humbled by that.
DARPA is not one person or one place. It's a collection of people that are excited about moving technology forward.
Hello, and welcome to Voices from DARPA. I'm your host, Tom Shortridge. If you were at Black Hat in 2023, you might have heard the event's founder, Jeff Moss, say this.
I frequently say that our community has a lot to offer, and the problems of AI are global problems. And so with that, we are making a surprise announcement. From the people that brought you the internet, DARPA, I would like to introduce Perry Adams. DARPA is seeking our help in an initiative of their next generation AI defensive technology.
Challenges have the power to drive innovation and bring together diverse talents to solve key challenges, which is why I'm excited to be here today to announce a challenge that I hope will do just that. DARPA's AI Cyber Challenge will ask the best and the brightest in AI and cybersecurity to defend the software on which all Americans rely.
Let's rewind. What does that mean, and how did we get here? On this episode of Voices from DARPA, we'll take a deep dive into the agency's latest challenge competition, the AI Cyber Challenge, and hear from the key players about why now is the right time to take advantage of the recent advances in the fields of artificial intelligence and machine learning. Our society runs on software, creating and expanding attack surface for malicious actors. Despite significant gains in secure software development practices, even today's cutting-edge security tools fail to address these risks at scale. Here's Perry Adams again. She's the program manager for the AI Cyber Challenge, on how she got involved in the field in the first place.
When I was in college majoring in computer science, someone invited me to the Capture the Flag, the CTF club, and I absolutely fell in love with it. And that's how I learned things about vulnerabilities in software and how hackers might turn those vulnerabilities into a way to do malicious things to that software and how we can protect against it. And I learned a range of skills from reverse engineering to binary exploitation to application security and cryptography for these competitions. Following graduation, I still competed in these competitions in addition to joining Boeing Defense, where I worked on the security of their mission critical systems. Following that, I went to 26 Technologies. There, I worked on a number of DARPA projects. That was actually my first introduction to DARPA. What was fantastic about that experience was that I got to work on a DARPA program called Chess. And essentially, I got paid to play CTF. We were the control team of expert hackers that was being pitted against the computer-human teamed systems that were being designed on chess to find vulnerabilities in software. So I got to not only focus on training a team of folks to actually compete against really the cutting edge in software security tools, but then work on a number of other projects that focused on a similar area in the space of what we call program analysis, which is developing methods to automate different parts of understanding code. So understanding where a vulnerability might be, understanding how to find it and fix it. Following that, I joined DARPA as a contractor where I was advising on DARPA programs. And following that, I became a PM.
While it shares the same name of the backyard game Capture the Flag, or CTF, the computer competitions are slightly different.
We're not running around capturing flags from other people. The reason it's called Capture the Flag is rather than hack into other people's computers, you hack into computers that have been set up for the competition. And the way that you show that you hacked into the computer is there will be a flag file stored on the computer. And so once you hack into the computer, you open the file and it has a string of characters that has some words in it, essentially, something that you can't randomly guess. And you submit that flag, as we call it. And that tells the people running the competition, hey, you were able to successfully hack into that computer. There's some other versions of this where you might be doing some reverse engineering. A flag might be what we call obfuscated or hidden in that binary, that compiled computer program, and you have to reverse engineer it out. And so that's another way that challenges in Capture the Flag manifest. But ultimately, it's a way for people to explore hacking in a safe, fun environment. And it really drives a lot of innovation in the computer security space.
Back in 2016, a previous DARPA challenge, the Cyber Grand Challenge, held its final event at DEF CON 24.
Welcome, everyone, to the first ever fully automated cybersecurity automated competition.
CGC was the first head-to-head competition between some of the most sophisticated automated bug hunting systems ever developed. These machines played the classic cybersecurity exercise of Capture the Flag in a specially created computer testbed, laden with an array of bugs hidden inside custom, never-before-analyzed software. The machines were challenged to find and patch, within seconds, not the usual months, flawed code that was vulnerable to being hacked, and find their opponents' weaknesses before they could defend against them.
Cyber Grand Challenge represented a major leap forward in automatic vulnerability discovery and remediation, and it created first-generation AI to solve that problem. So it pioneered novel program analysis approaches that encode expert reasoning and logic about automatically understanding code and understanding vulnerabilities and identifying them and remediating them into these reasoning systems that could then autonomously find bugs in software and suggest fixes for them. Now, when I say first generation AI, that's because there wasn't actually a lot of or any machine learning used in the finals of Cyber Grand Challenge. However, since Cyber Grand Challenge was run, that was 7 years ago, we've seen enormous advances in machine learning. Now, AICC isn't another Cyber Grand Challenge, but there's elements of it that really will build on top of the amazing gains made in Cyber Grand Challenge.
Recent years have exposed countless cyber threats facing society caused by malicious cyber actors, and highlight the daunting attack surface cyber defenders are tasked to protect. AI, including large language models, can be used for the common good. That's why DARPA is bringing together leading AI researchers to leverage this technology to protect and defend software that powers our critical infrastructure. While the exact structure and gameplay is yet to be revealed, the AI Cyber Challenge consists of 3 competitions: the qualifying competition, the semifinal competition to be held at DEF CON in 2024, and the final competition to be held at DEF CON 2025. Each competition will feature challenges designed and evaluated by a team of subject matter experts, who will give teams a large suite of challenges based on real-world, critical, open-source, and critical infrastructure software. Teams will design AI-driven systems to find and fix vulnerabilities within these challenges. At the heart of the competition is the desire to apply this new technology to solve real problems we still face as a society.
So securing large amounts of software running on these critical systems at scale is a major issue. And so we're going to be looking at software that might be found on a water treatment plant or an electric grid, and we're going to be securing that software in real time. We want the software that we're securing in this competition, the challenges, to really exemplify the issues seen in the real world today. We want these challenges to drive the development of systems that will be applicable to real world problems. And so we're modeling our challenges on top of open source software, because open source software is actually the software that undergirds most of society. It makes up nearly 80% of some critical infrastructure sector's software, and it is incredibly important in everything from commercial software to the software running within government systems to the software running on your home router or your home computer. It is so ubiquitous, and so critical in software supply chains as well as in our critical infrastructure. So this is an opportunity for us to have really the experts in open source security come in, advise us on what kind of issues, what kind of vulnerabilities they're seeing today, as well as helping us to design tools that really help to fix those issues in the real world.
These experts include the Open Source Security Foundation, or OpenSSF, a project of the Linux Foundation. We spoke with OpenSSF's general manager, Omkar Arasaratnam.
Open source software is everywhere. Whether you're using it for your mobile phone to take a video, to the power plant, to potentially even the actuators in the water and sewage plant that's in your neighborhood. The Open Source Security Foundation was founded in the summer of 2020 in recognition of the fact that the accountability for security of open source didn't fall on one maintainer or a tech company or a operator of critical infrastructure or public sector or private sector. It was everyone's accountability. And the OpenSSF was built in order to provide a means for all the stakeholders to gather together and to improve the security of open source software for the greater public good. The reality is any software that's developed has the same kind of quality concerns, and it could occur in open or closed source. One of the things that makes it a little easier to secure open source is it's open. The software is available there for everyone to look at. Now, previously, there was this assumption, the source code's out there, it's insecure. I think we've pretty much rendered that to be incorrect. Source code out there doesn't mean that anything is less secure. And in fact, if you're relying on obscurity as a security property, you should probably rethink your security architecture. And then we went to this extreme where we said, it's all open source. And with thousands of eyes, all bugs are shallow. And we realized that wasn't quite the case either. So I think when it comes to either open source or closed source, it is much less about the license or the availability of source code and much more about how the developers are focused on ensuring that the security properties are present. And most importantly, because we're all human, when a vulnerability is discovered, how quickly and efficiently we address that vulnerability.
As you've heard before, infusing reality into the AI Cyber Challenge will be essential to the success of the competition. Omkar explains the OpenSSF's approach to making the transition from a challenge environment into the real world a smooth one.
The primary guidance that we're going to be providing DARPA through the execution of at least the initial part of this challenge is to ensure that the manner in which the challenge is constructed, the things that we're waiting on in terms of success, how we're evaluating submissions, is going to be in a way that the open source community will be able to consume. We would hate for the challenge to be constructed in a way that we have all these great technologies created, but it just doesn't align with how open source software is developed. So that's one. Second, as we're progressing through the challenge, we hope to engage members of the community, solicit their input, obviously maintaining the confidentiality of the challenge as we need to, but to seek input from the community in proper open source style so that this feels like an effort that the community has been involved in versus something that's been done to them. The last thing that we want to ensure, and this starts to look more to 2025, once we announce the winner, the question is, hey, so now what? So we want to be able to provide a nice, smooth off-ramp back into the community for all this great software that's going to be developed so that it just doesn't end with the challenge, but becomes this sustainable way of securing open source software for future generations.
We often talk about DARPA being part of an innovation ecosystem, how the agency doesn't do things by itself. That's certainly the case with the AI Cyber Challenge. In addition to OpenSSF, DARPA's also collaborating with Anthropic, Google, Microsoft, and OpenAI to help competitors develop state-of-the-art cybersecurity systems. When it comes to DARPA challenges, Matt Knight, who was OpenAI's head of security, is no stranger. He competed in the open track for DARPA's Spectrum Collaboration Challenge, or SC2. We spoke with him about his experience to glean some insights about what future competitors can expect with the AI Cyber Challenge.
My first formal engagement with DARPA came via the Spectrum Collaboration Challenge a couple of years ago. The Spectrum Collaboration Challenge, SC2, was an open and competitive challenge to develop novel radio algorithms to solve spectrum scarcity and congestion. A problem that telecom operators and people building wireless systems need to contend with is that the radio spectrum that radios use to communicate is a scarce resource. It's statically allocated, it's not efficiently utilized today, and as a result, radio networks aren't as efficient as they could be. They also are brittle to certain types of attacks like jamming and things like that. So DARPA had a kind of a cool approach to solving it. They wanted to spur innovation in cognitive radio, which is the application of AI and innovation in multi-agent systems to get radios to self-organize, to be both more efficient and more resilient. And the challenge was really a perfect confluence of sort of my skills and interests at the time. It was algorithms and AI, signal processing, multi-agent systems, some systems engineering, high-performance software development, which was really interesting. And the format was also quite unique and facilitated participation of a non-traditional entrant like me. I participated in the challenge with close friend and former colleague Mark Newland, who himself is a glutton for DARPA challenges. He competed in some image recognition challenges back years ago, and then in the first Spectrum challenge. So, we were really just like two guys in our nights and weekends who were able to access this really cool program, largely because DARPA is able to run events like this in ways that are open to individuals as well as companies that are able to take on government contracts and things like that, which, we as just like two guys obviously couldn't do. I would say that non-traditional entrants need not be intimidated. Yes, it's DARPA. Yes, it's a government program. DARPA sets up programs like this to be accessible to lone wolf entrants, just like my colleague Mark and I were in the Spectrum Collaboration Challenge, as well as sort of more traditional competitors. But if you sort of have a non-traditional background and normally wouldn't reach out for something like this, that need not apply. You should go for it anyway. The fact that there are AI platforms available, things like the OpenAI API, other services like it that will be available to competitors, means that participants also don't need to be AI experts. Because you can interact with powerful AI systems through APIs, security researchers who normally might not have the skills to build or train or deploy their own AI system can still leverage the tools that are needed to participate in this challenge. So I'm optimistic that and hopeful that a push like this is going to lead to the creation of many companies and tools that are going to reach beyond this program to help developers fix vulnerabilities in the code that they're writing and write more secure software in general.
His team may not have won SC2, but we pulsed Matt for some of his lessons learned about what it takes to be a successful competitor and got his take on what's in it for competitors beyond the prize purse.
A few reasons why people should consider participating in the challenge. One is you'll have the opportunity to develop tools and technology that will have an impact on a critical security domain, which is the security of open source software that powers all the critical software infrastructure in the world. It's a really important scope. I hope that objective alone is enough. But beyond that, obviously there's some prize money involved. You're going to get access to OpenAI's technology, models and tools like GPT-4 and ChatGPT. As a technology partner, we're going to be providing abundant API credits and access to those tools so that competitors can innovate and explore and not be bound by that. One thing that I would impart for competitors is that the rules really matter, scoring specifically. It was a big factor in terms of how we built and designed our technology for Spectrum Collaboration Challenge, just given the rules of the game. The scoring rules for the AI Cyber Challenge haven't been released yet. I think they're coming out later this fall, so stay tuned for that. One other thing that was interesting in reading the scoping for the AI Cyber Challenge is the focus on finding and fixing memory corruption vulnerabilities. Early research done by the security community using language models shows that language models like GPT-4 aren't phenomenal at that type of bug class, or at least are less capable there compared to other types of bugs and security applications. I think that's also why it's important to foster research in this area. I guess what I would say to competitors is, DARPA is going to tell you the types of problems they want you to work on and focus on, so listen to them. They will lead you in the right direction.
We asked Omkar to weigh in as well.
So I'm a firm believer that there's a certain way of thinking that got us into the security problems we have. And that thinking tends to be very monocultural and tends to be very focused on how we were taught computer science in school. That's what it all comes from, right? I would love to see an incredibly diverse set of responses coming from people that, hey, maybe you were self-trained in software engineering. Maybe you don't have an undergrad. I don't have an undergrad. Maybe you didn't get your doctorate from an Ivy League. I would love to see those individuals coming up with really novel ways of solving this terribly pervasive set of security problems that we have. The advice that I would have Folks, this is a DARPA challenge. This is time for the moonshots. Bring out all the big, heady ideas, shoot for the stars, and let's see where we get. There's ample opportunity for us to be able to think of things in an incredibly novel way, because the way that we've been trying to do it hasn't solved these problems pervasively. So I'd encourage those that are considering participating, bring your wackiest ideas, bring the ideas you don't think are going to stick, and let's see how they fare.
And here's Perry again on who she hopes will take part in this opportunity to change the cybersecurity paradigm as we know it.
The competition will be open. Anyone can compete in the competition who registers subject to some eligibility requirements that are outlined on aicyberchallenge.com. I'm really excited with the level of engagement we've seen following the announcement, and I'm hoping to see all kinds of people participate in this challenge, from academic researchers to folks working in computer security in industry today, to folks from the traditional DARPA research base that has been working on similar program analysis problems on different DARPA programs. And we're seeing that level of engagement. So I'm hearing from people at major software companies that are thinking of leaving and forming their own small business to compete. And that's something I'm very excited about as well, is that in order to encourage participation from not just different areas of research from academia to industry, but from different sizes of businesses as well. We are in an age of incredible innovation when it comes to AI and machine learning. We're seeing really fantastic advances that have significant potential when applied to problems like computer security. And competitions have been great driving forces, especially at bringing together folks from disparate scientific fields, disparate research backgrounds, and bringing them together to drive innovation forward in an area that hasn't necessarily been explored as deeply before. I think DARPA is an amazing driver of research, and I'm biased, but I'd say especially in computer security work, where the U.S. government really sees this as a critical area for national security. Software security is national security, and DARPA has really pioneered many of the advances over the last 20 years in the software security space. That's why I was very excited to come to DARPA, and that's why I think other people should be excited to work with DARPA.
The AI Cyber Challenge Open Track registration will begin later in 2023. And don't forget to visit aicyberchallenge.com for complete and up-to-date competition information. If you're planning to participate in the AI Cyber Challenge, why not let us know on social media? That's it for this episode of Voices from DARPA. Thanks for listening. And special thanks to Heather Dees for her assistance in producing this episode. If you have questions about the podcast or want to suggest a DARPA topic for us to cover, you can email us at podcast@darpa.mil.